Okay, the recording is on.
Hello, sir. I am Jishu Junaid. Now I am presenting my CO1 presentation. So here we can see a question that is each of the following languages is the intersection of two simpler languages. In each part, construct DFS for the simpler languages. Then combine them using the construction discussed in footnote 3 to give the state diagram a DFA for the language given in all parts of AB. So here the first question, W such that W has at least three A's and at least two B's. So for that, the solution is the following are DFS for the two languages. That is, language one is W such that W has at least three A's. For this, the string AB, the state diagram like this Q0. If we give the A Q1. If we give the here A, then we also get Q2, and if we give here A Q3. Uh, as there are tell ki at least three A's, so we need to three state, at least three state. And if we give Q0B, then it will become Q0. If Q1 yeah, give B, then it will Q1. If there you get give we B in Q2, we also get Q2 and Q3 also B. So this is for language one, and for language two, W has at least two B's. For that, we consider three state R0, R1, and R2, and this is the state diagram for language 2. Now, we are combining them using intersection construction gives the following DFS. If we combine language 1 and language 2, we get this diagram, and this is the final diagram for uh, W has at least three A's and at least two B's. Now, the second question said that W such that W has an even number of A's, one or two B's, even number. So for that, if we conflict in two languages, so first language W such that W has an even number of A's. For that, R0 and R1, here we need to two state, and this is the state diagram for language 1. And for language 2, which is W such that W has one or two B's. For that, this is the state diagram for language 2. And next, we combine two DFS, two language, and get the final language, that is W has an even number of A's and one or two B's. So, combining them using intersection construction give the following DFS Q0R0, Q0R0. This is the final state diagram. Now, next we can see a problem from NFA to DFA conversion. If we convert this NFA to equivalent DFA, this state diagram, first we need to draw the transition table, which is presented input A and input B. Here we can clearly see this present state is 1 or 2. Present state 1, there is epsilon 2, 2. So the present state is 1 and 2. So if in present state 1, 2, if we give the input A, we can get 1, 2, and 3. And in state 1, 2, if we get B, we get null, that is 5. So the next present state is 1, 2, 3. So if we give B A in 1, 2, 3, we get all 1, 2, 3. And if we give B, then we get 2 and 3. So our next present state is 2 and 3. So in 2 and 3, if we give A, then we get 1 and 2. And if we give B in input, so then we give 2 and so we get 2 and 3. So this is the transition table, and the equivalent DFA state diagram like this. If we give 1 to input A, then 1 2 3, and this is the final state. For this, 2 is final state. So in DFA, in where 2 are present, they all are final state. So there we can see all are final state. And 5, this is end state. So this is the equivalent DFA of this NFA. Thank you.
Hello, sir. I'm Junaid and I'm here to give my presentation on CA1. So the first question is the following are the state diagram of DFA M1 and M2, and I have to answer the following questions about these each machines. So in M1, what is the start state? So the start state is Q1 because it has the incoming arrow without origin. And number two question is, what is the set of accept states? So the accept state will be Q2 because it has double circle. That means it accept state. Again, now the next question is, what sequence of state does the machine go through and input AABB? So it will start with Q1. A will move to Q2 and A will stay at Q2. Then B will move to Q3, and for B it will stay at Q3. So the final state will be Q3 and it will not be a accept state. So and the next question is that does the machine accept the string AABB? So the answer will be it does not accept AABB because final state Q3 is not accepting. And the last question for machine M1 is that the machine accept string 6. So the answer will be it does not accept because start state Q1 is not accepting. So, and we will see the next set of question for M2 machine. It start state will be Q1 because it has the incoming arrow without origin. Uh, its set of accept state will be Q1 and Q4 because they are accepting and they have double circle means they will accept state. What sequence of state does the machine go through and input AABB? So it will start with A Q1. For A, it will move to Q1, and for again A, it will stay at Q1, and for B, it will move to Q4, and the final state will be Q4. That will be accept state. So next question is the machine accept the string AABB? Yes, it accept AABB because the final state Q4 is accepting. And the last question for the machine B is, does the machine accept string C? Yes, it accept E because the start state Q1 is accepting. Now the next question is, design an NFA for a language that accepts all strings over 0, 1 in which the second last symbol is always 1, and then we have to convert it into its equivalent DFA. So here we can see example that the last symbol is always 1, like 1010, 110, 110, 1010. So the NFA diagram will be, it will start with A and we will have a loop and 0, 1. If 0 comes, it will go in the loop. If 1 comes, for according to the question, it will remain in the loop or it will go forward to the B. And if 0 comes, then it will go to the C. So here we can see in the diagram, yeah, the start with A. If 0 come, it will stay in the A. If A come, it can stay in A, or it can go to the B. Or for B state, if 0 come, it will go to the C. It will 1 come, it will go to the C. And now for the DFA, we will have this the following diagram. It will start with A. If 0 comes, it will stay in the loop. If 1 comes, it will go to the AB. Now new state will be AB. If 0 comes, it will go to the AC. If if 1 comes, it will go to the ABC. Now we will have two new states, AC and ABC. So if in AC, if 0 comes, it will go to direct A state, and for ABC, or if 1 comes, it will go to AB. And for ABC, if 0 comes, it will directly go to the AC, and for 1, it will remain in the ABC. So in FA diagram, the accepting state is C, and in DFA diagram, the accepted state is ABC and AC. Thank you, sir.
Hello, sir. I'll be presenting my CA1 presentation on the topic we have. So, firstly, I've taken a question from MSIPS's Automata book. So, the question states that the formal description of a DFA M is given as it is given in the form of 5 tuple, which states that the first tuple states there are 5 given states Q1, Q2, Q3, Q4, and Q5. Then we have the input symbols as U and D, which is given in the alphabet. Delta is the transition function, and Q3 is both the initial state and Q3 is the final state here. So, according to the transition table which is given, we need to draw the state diagram of the machine. So, according to the transition table, Q1 is the starting state, and for each input U, we have all the outputs which we get the transitions for each input states Q1, Q2, Q3, Q4, and Q5. So, in order to create these the state diagram, we consider all 5 given states, the Q1 to Q5, the input symbols, and the initial and final state. So firstly we have Q3 as the final state and the initial state. So on Q3, when U input is put, then we go to the next state Q2. When in Q2, when U input is given, we go to the state Q1. Now for Q2, when the input is D, we come back to Q3, and similarly for Q1, when input is D, we come back to Q2. Now for Q1, when the input is U, we see that there is no transition and it stays in its own state Q1. So we loop it back to Q1. Similarly for Q4 and Q5, on applying the input U and D, we get the corresponding transitions, that is Q3 and Q4 respectively. So thus we get the given deterministic finite automata. Here we have the summary of this deterministic finite automata for the given states, the alphabet which is the U and D, the transition function delta which is given in the table, the start state Q3, and similarly the final state is also the same Q3. Now moving on to the next question, we have a milli machine to moon machine conversion. A milli machine diagram is given and the transition table for this milli machine is also given. So according to the transition table, for present state Q0, on input state A, we go to the we have a transition for the state Q2 and we get a output 1. Similarly, for input B, we get a transition to Q3 and we get output 0. So for remaining inputs Q1, Q2, Q3, we get the outputs. But here we see that for state Q2, we get two different outputs, that is 0 and 1. And similarly for state Q0, we get two different outputs, 0 and 1. And for state Q3 and Q1, we have only one single output. For Q3, we have output as 0 when a transition takes for Q2. And from Q3 to Q0, when transition takes place, then we get a output 1. So that we prepare a transition table for the Moore machine, which will be given as follows. Now we take the help of the transition table of milli machine to prepare the transition table of the Moore machine. So firstly, we have Q0 by 0, which means that for when Q0 has output 0 and input A is given, then a transition takes place for Q2 and we get an output of A. Now, when Q0 has output 0 and input is B, then we get a transition to Q3 which gives us a output 0. So the output remains 0 here. Similarly for Q0, when output is 1 and input is A, we get a transition from Q0 to Q2, and for this transition we get an output of 1. And when Q0 has output 1, a transition and input is given B, then a transition from Q0 to Q3 takes place and we get an output of 0. So here the output remains 1, as for Q0 we get an output of 1. Similarly, for Q1, when output is 1 and input A is given, then we get a transition to Q0 and output 0. And when input is B, then we get a transition to Q1 and input 1. So after preparing the corresponding table, we can prepare the Moore machine diagram. This table represents the Moore machine, which we obtained from the milli machine. So here we can see that when Q0 has output 0, input B is given, that it then a transition takes place from Q0 to Q3, which gives an output 0. So according to Moore, in Moore machine, we can see that when transition takes place, one state can have more than two outputs. Thus, we can conclude the Moore machine here. Thank you.